Okay, let's take a look at the Chapter 8 review worksheet. Remember, Chapter 8 covered the Pythagorean theorem, and that's where we're going to start. That is a squared plus b squared equals c squared. So in this first triangle, that would be 84 squared plus b squared equals 85 squared. Gives me 7,056 plus b squared equals 7225. So b squared is equal to 169. B is then equal to the square root of 169, which is going to be 13. Number 2, again, that's the Pythagorean theorem. So I have 12 squared plus 13 squared equals c squared. So 144 plus 169 equals c squared. So the square root of 313 is c. And if you think about that, you can't divide that by 4 or any even number evenly. And if you try to divide it by 9, you don't get an even number. So you can stop right there. That one is actually in simplest radical form right there. Okay, classifying angles as acute, obtuse, or right. Remember, when they are equal, that is a squared plus b squared is equal to c squared. It is a right triangle. When a squared plus b squared is greater than c squared, it is acute. And when a squared plus b squared is less than c squared, it is obtuse. So the first one, I get 25 plus 64, and how's that related to 121? Well, that would be 89, so it is less than. So the sum of the squares of the legs is less than the longest side, so that's going to be obtuse. The next one, that's 64 plus 81. How's that related to 144? 64 and 81 is 145, so that's greater than 144. Therefore, that makes this an acute triangle. And finally, 7 squared is 49, and 24 squared is 576. How does that relate to 25 squared, which is 625? If you sum those two, you'll find they're equal, and that is a right triangle. Okay, now let's go back. We're going to take a look at that idea of 45, 45, 90, and 30, 60, 90 right triangles again. Remember, there's going to be a couple ways I'm going to list both ways of looking at these problems. When I have a 45, 45, 90 triangle, it is similar to every other 45, 45, 90 triangle. So two ways of looking at this. One is to use the reference triangle. So if I want to use the reference triangle, I would say that I have the leg of my reference triangle is to the leg of the triangle in the problem, as the hypotenuse in my reference triangle is to the hypotenuse of my example problem. So now I get a proportion, and I can cross multiply. And I will get 13 times the square root of 4. Square root of 4 is 2. Therefore, C is 26. So one of the methods would be to solve the proportion. Set the proportion up using the reference triangle and solve that proportion. The second is to remember the formula that the hypotenuse is equal to the length of the leg times the square root of 2. So then go to your triangle and fill in the information. The hypotenuse is C. The length of the leg is 13 square root of 2 times the square root of 2. And again, you're going to get 13 times the square root of 4. Square root of 4 is 2, so you get that C is equal to 26. So again, you can do that either way, either using the reference triangle or using the verbal equation. Let's take a look at number 7. Now this is a 30, 60, 90 triangle. So my reference triangle for this will be 1, square root of 3, and 2. So I can set up the proportion and say that the reference short leg is to the example short leg as the reference hypotenuse is to the example hypotenuse. So again, I can cross multiply. I will get A is equal to 2 times 2 root 3. So A is equal to 4 root 3. For B, I can set up that same comparison. So the short leg is to the short leg 2 root 3 as the long leg square root of 3 is to the long leg B. And again, cross multiply, so B is equal to 2 root 3 times root 3. So that's going to be 2 root 9. The square root of 9 is 3, so B is equal to 6. So that's one way. The other way that we're going to look at is remembering the relationship. So the hypotenuse is equal to the short leg times 2. Now substitute the information in that you have. Hypotenuse is A. The short leg is 2 square root of 3 times 2. That will give you 4 square root of 3. To find B, the long leg is equal to the short leg times the square root of 3. The long leg is B. The short leg is 2 root 3 times the square root of 3. When you multiply that, you get 2 times the square root of 9. 2 times the square root of 9 is 3. That gives me an answer of 6. Okay, let's look at the next one again. I have a 30, 60, 90 right triangle. My reference triangle. Here is my 30-degree angle. Here's my 60-degree angle. So the relationship is the short leg is 1, the long leg is root 3, the hypotenuse is 2. So again, I can set up these ratios where I'm comparing my standard triangle to my example triangle. So I have the short leg of my standard triangle is to the short leg of my example as the long leg of my standard triangle is to the long leg of my example. Now I can cross multiply and I will get 15 square root of 3 equals x times root 3. Divide by root 3 and you'll get that x is equal to 15. Then once you know the short leg, it's pretty easy to find the long leg. So now this is 15. So if I take the relationship between the short leg, 1 is to 15 as 2 is to y. Cross multiply, you'll get that y is equal to 30. Okay, then again, you can also remember these statements. Okay, if you're just looking at the triangle, the hypotenuse is equal to the short leg times 2, and the long leg is equal to the short leg times root 3. So substitute it in. You have the long leg, so that's the one you're going to start with. That's 15 square root of 3 is equal to the short leg x times root 3. Divide both sides by root 3, and you will get the short leg is equal to 15. Now go back up to find the hypotenuse. The hypotenuse is y. The short leg is 15 times 2, so y is equal to 30. So we got the same answers, and you can choose either method, whichever one makes more sense to you, and you can do more accurately. Number 8, now I have a 45, 45, 90, so I will go to my standard triangle again. That's 1, 1, square root of 2, and I can set up that comparison. The leg is to the hypotenuse as the leg is to the hypotenuse. Cross multiply, you're going to get 8 square root of 6 over the square root of 2 equals b. Now here's a property, I'm not sure if you remember this or not, but if you have the square root of a over the square root of b, you can write that as the square root of a over b. And therefore you can simplify that much easier. So now this b then becomes 8 times the square root of 6 over 2. That reduces to 3. So 8 square root of 3 is b. And a is the same because that's an isosceles right triangle. So a and b are the same. Again, for this, you could remember that the hypotenuse is equal to the leg times the square root of 2. So the hypotenuse is 8 square root of 6 times the leg, which is a root 2, divide by root 2, and again you will get 8 square root of 3 as a and b. Next, okay, we're done with 30, 60, 90 triangles. So now we have to look at our reference angle and identify the legs that we have. Here's the hypotenuse. That makes this the side opposite and this the side adjacent. So I want to find a and b. So the first one I'll find is a. So sine of 53 is equal to a over 21. The variable is up high, so you multiply. 21 times sine of 53 equals a. So a is equal to 16.8. Then to find b, that's the adjacent side in the hypotenuse, so we will use cosine of 53 is equal to b over 21. Again, the variable's up high, so you multiply. 21 times cosine of 53 equals b. So b is equal to 12.6. Okay. The next one, number 11, again, I'm going to use the trig ratios. I have the side opposite, I want the adjacent, and I want the hypotenuse. So to find the hypotenuse, I will use sine of 27 is equal to 12 over c. Now this time the variable's down low, so they trade places, so therefore sine 27 and c trade places. So c is equal to 12 divided by sine of 27. So c is equal to 26.4. Then to find the side adjacent, I will use tangent of 27 is equal to 12 over the side adjacent a. Again, the variable's down low, so they trade places. So a is equal to 12 divided by tan of 27. Therefore, a is equal to 23.6. Moving on to number 12. Now, number 12 is a little more challenging. We have to look at two different triangles. We're going to start looking at this first triangle right here. And we're going to find the value of x. Again, I have to identify my legs. I have the side opposite. I want the side adjacent, so that's tangent. So tangent of 58 is equal to 15 over x. The variable's down low, so they trade places, so x is equal to 15 over tan of 58. That tells me that that is equal to 9.4. So this is 9.4. So now I have to set up another ratio, this time looking at the entire triangle, which is this entire area. Again, I'm going to use tan because I have the opposite, and I'm looking for a part of the adjacent. So I have tangent of 34 is equal to 15 over y plus 9.4. And because this one is just a little more complex, I'm going to go ahead and find the value of tan 34 and put that in so it makes the algebra look just a little bit easier. So tangent of 34 is equal to 0.675. Now I will multiply both sides by y plus 9.4. So on this side, remember they cancel. You do not multiply that numerator. They cancel. Now on the left, I'm going to distribute, so I have 0.675y plus 6.345 is equal to 15. Subtract the 6.345, then you should get 0.675y is equal to 8.655. Divide that 0.675 out of both sides, and y is equal to 12.8. So that one was a little longer, a little more complicated, but you should be able to follow that process. And again, if it's going to get pretty complicated algebraically, just go ahead and find the value of that trig ratio or that angle in your calculator. That makes it a little easier. Okay, let's take a look at 13. Now 13, I'm looking for the angle measures. So I'm looking for the angle measure. I have the side opposite my reference angle, and I have the side adjacent my reference angle. So I'm going to say tangent of y is equal to the opposite over the adjacent. So now I take the inverse, y is equal to tan inverse of 15 over 21. So y is equal to 36 degrees. Then I can change and now make x my reference angle for the second one. So that would be tangent of x is equal to 21 over 15. Again, take the inverse of both sides, and you will get that x is equal to 54 degrees. Remember, those two should add up to be 90 degrees. It's a right triangle, so the sum of the interior angles is 180. It has a right angle, which is 90. That means those remaining two angles must sum to 180. Or must sum to 90. I'm sorry, sum to 90. Last two. Okay, to approach the runway, a small plane, so here's my small plane, must begin a 4-degree descent. So this is going to be an angle of depression, of 4 degrees. Remember, that's this angle that is the angle of depression. Starting from a height of 3,225 feet to the nearest mile. Oh, there's a tricky part. To the nearest mile, where does this runway begin? Now the runway's out here, but that's not going to help us with our triangle. Okay, so remember these two are parallel. If this is an angle of depression, then that is also 4 degrees because they are alternate interior angles. So I have the side opposite, it says to the nearest tenth of a mile, how many miles from the runway is the airplane. So that's this distance, which is the hypotenuse. So I have the opposite, I want the hypotenuse, that's going to be sine of 4 is equal to opposite 3,225 over the hypotenuse d. The variables down low, they trade places. D is equal to 3,225 divided by sine of 4. Therefore, D is equal to 46,232 feet. You're asked for miles, so you have to divide that by 5,280, and you will get approximately 8.8 miles. So the plane is approximately 8.8 miles from the runway. Finally, number 15 says to find the height of a pole. So here's the pole. A surveyor moves 200 feet away from the base of the pole with a transit that is 5 feet off the ground. So this is 5 feet right here. He measures an angle of elevation of 36 degrees, and we're looking for the height of the pole. Remember, x now is just going to be this part of the pole. I'm going to have to add that 5 feet. So I have the adjacent, I want the opposite, that's tangent. So tangent of 36 is equal to x over 200. The variable's up high, so you multiply. 200 times tangent of 36 equals x. And you should get 145.3 equals x. But remember, we have to add that 5 feet because that's the amount that it is elevated by that transit. Therefore, 150.3 feet is the height of the pole. Okay, and that's the end of the review sheet. I will see you tomorrow.